sketch the graph of y is equal to cosecant 1/3 x. So first off, we're going to recognize the transformations compared to the original cosecant function, which you see we have this 1/3 here, and we know that since the general form of transformations is the h value in the front, and then b times x minus h in the middle, and k at the end, we know that this 1/3 corresponds with the b value, the coefficient of x, and so we know b represents the horizontal expansion or compression, and actually the expansion or the stretch will be the reciprocal of this value. And so what this means is it's actually a horizontal expansion by a factor of 3, even though it's 1/3. And so all we need to do is take every coordinate on the original graph and multiply its x coordinate by 3, so x becomes 3x. So I plotted a bunch of points on the original graph. You probably don't need to plot all these points, but it's kind of good to see how the behavior of the graph. And even though it looks like a lot of writing, all I did was I took the x coordinates and I multiplied it by 3. See, pi over 4 became 3 pi over 4, pi over 2 became 3 pi over 2, etc., etc. And also remember on the cosecant graph, cosecant is 1 over sine. And so I'm just looking for 1 over sine pi over 4, 1 over sine pi over 2, 1 over sine 3 pi over 4, etc. And so when I plot all of these points, you can see that this is one period from 0 to 6 pi because, again, we've been expanding horizontally. And so I just plotted the points. 2 over root 2 is about 1.414. So 1.4, I just kind of plotted there. And you can see negative root 2 over 2 is over here. And yeah, so it just goes up. And you know the asymptotes occur at 0, 3 pi, which originally was pi, and 6 pi, which was originally was 2 pi. And so this is one period. If you want to draw more or sketch more than one period, you just repeat this to the left or to the right. And there you go.